Instantiating and destroying objects involves a lot of processing. Instead of going through this expensive cycle of creating and discarding objects, why not recycle them? That's what object pooling is all about. Just think of object pooling as like reusing arrows. Instead of crafting a new arrow every time you want to shoot, you can simply pick up an arrow off the floor, or stuck in a zombie's head, and then put it back in your quiver for future use. Object pooling pre-creates a pool of instances of a game object, like arrows in a quiver, and keeps them deactivated. When you need to use an object, simply activate it and place it where you need it. Starting from Unity 2021, Unity provides its own object pooling API. That will be the focus of this video using the gun turret example from the Design Patterns ebook linked below. Before we go step-by-step through things, let's first take a look at what our code will eventually do. In the gun class, called Revised Gun in the ebook example, if fire 1 is pressed in fixed update after a time delay, instead of using instantiate, we use get to retrieve an object from the pool. And in the projectile class, after an amount of time of being alive, instead of using destroy, the projectile returns itself to the object pool with release. So in this example, the projectile has reference to the object pool, which is also convenient for returning itself on collision. Alright, let's rewind and start from the top with the variables in the gun script. At the top of the script, include unityengine.pool, the namespace that allows us to use Unity's object pooling API. The ebook example script has tooltips for the serialized fields for easy understanding. Projectile prefab is the prefab with the projectile script. We'll look at that again shortly. The muzzle velocity field allows you to control the speed of the projectile directly from the gun, which is nice to have centralized here rather than on the projectiles. Muzzle position is the starting point for the bullets. Cooldown window is the time duration between consecutive shots, this way the bullets don't fire too rapidly. And next we define an interface iObjectPool parameterized with projectile. This sets up the object pool specifically for storing and managing projectile instances. Collection check is a safety feature of the pool. When enabled, it checks if you're trying to add an object back to the pool that's already there, and throws an exception if that happens. The check is only performed in the Unity editor for debugging purposes. If you're not running into any issues, you can turn it off. The default capacity and max size fields help you define the initial and maximum size of the object pool. It's computationally expensive to frequently resize the pool, so set your default capacity such that it doesn't need to be expanded too often. Max size acts as a hard cap, ensuring that the pool doesn't grow uncontrollably. And next time to shoot is a private field used to manage the cooldown between shots. Now in Awake, we create a new object pool, and here we have the constructor which has several parameters. As we walk through this specific implementation, let's also look at the object pool's constructor in the API. That way we can look at each method in context. We've already looked at the collection check, default capacity, and max size, so let's focus on our first parameter, createFunc, which is of type func of t. This represents a delegate or function pointer which returns a value. In simpler terms, createFunc is like the set of instructions for crafting a new object when the pool is empty. Think of it as the recipe for making a new arrow if the quiver is empty, and it also returns that new arrow to you. In our example, the function is createProjectile, which returns a projectile object. The example sets an object pool property on the projectile instance. This way the projectile can have access to the pool. This is useful because the projectile can release itself back to the pool after a certain time or on collision. That creates a separation of concerns since the projectiles know about their collisions and how long they've been active. That's not stuff the gun script should have to be concerned with. Next, we have action on get. This action is triggered when an instance is taken from the pool, so you can use it to activate the instance. The method in the example is onGetFromPool, and there we make the game object active. Action on release is called when you return an instance back to the pool. Typically, you deactivate the instance here. So here we have onRelease to pool, where the projectile is deactivated. Then we have action on destroy. If the pool reaches its maximum size and you try to add another item, this action gets called. Usually, you'll use this to safely destroy the object. With the pool created and ready to go, all we need to do to get a projectile is object pool get. And just like we saw with a bow and arrow, we put the bullet in the position it should shoot from and add a force to the rigid body. At the bottom, we set the cooldown delay for the next time to shoot. And we can see here that we're invoking deactivate on the projectile, so let's take a look at the projectile script next. The projectile class has a public property to have reference to the object pool. When the gun invokes deactivate on the projectile, it starts a timer so that after the timeout delay, the projectile stops itself and returns itself back to the pool with object pool release. And there you have it, simple, straightforward object pooling. If you want to try creating your own version of the object pooling pattern or learn the other design patterns, check out the free ebook at the link below.